All right, multi-correct questions. We need two answers to be correct. Number 24, a satellite of mass m moves in a circular orbit of radius capital R, around a planet with a mass big M with speed v. Which of these must be true for the satellite? All right, so the net force on it is big M times big R over v squared. So net force, that wouldn't be the equation for net force. Its acceleration is big G, big M over R. That would be R squared. That's not going to work. So it looks like C and D, but let's take a look at it. Orbital velocity, we know, is velocity equals the square root of big G, big M over little r. But they said in this situation, the orbital radius is going to be capital R, so this will be replaced with a capital R or an uppercase R, so C definitely works. Orbital period, all right, so we know velocity is 2 pi r over period. If we flip the velocity in the period, we're going to get something that looks a whole lot like that. Number 25, spacecraft X has twice the mass of spacecraft Y. They orbit Earth at the same radius, so the orbital radius is the same. Which of these must be true? X feels a greater gravitational force than Y. Well, we know gravitational force is equal to big G times mass 1, mass 2, over the distance between the centers squared. So whichever mass is going to be greater is going to have a greater gravitational force. So A definitely works. Let's go down to about its speed, because this is all about time and speed. So we know orbital period. So let's see, we have velocity equals 2 pi r over period. Right? And we can flip-flop this, as we did before, and say period equals 2 pi r over v. And we know that orbital velocity equals the square root of little g times r, and we know that we're at the same radius, same g, which would mean the velocity would be the same, so the orbital period has to be the same.